In an INtime multicore system, we have to deal with management of multiple instances of INtime running on our multicore system. If I bring up the INtime configuration panel, in this particular system I've got a quad-core processor, cores numbered 0 through 3, and I've got a single core configured called control as a dedicated INtime instance. Let's add an additional, call it DSP, and now we've got a second INtime instance assigned to core 2. So cores 0 and 1 will run Windows in SMP mode. Core 2 will run an instance of INtime we're calling DSP, and core 3 will run an instance of INtime we're calling control. Now each of these cores can have separate parameters associated with it. For example, let's change the DSP core tick rate. This is a low-level INtime kernel clock tick to be 100 microseconds. We can even change the specific core that we'll have it run on here. We can change how much memory will be assigned to that core. We'll just leave it at the default of 16 meg. If we look at the control core, which was already in existence, it's also set to 16, but we have it running at 500 microseconds rather than 100 microseconds. We'll close this and we'll restart our system. Now when we look at the INtime control icon, we'll see there are two instances of INtime with the names we gave them that we can start individually or start all. So let's start all the instances, and we'll start the INtime Explorer. Within the Explorer, we've got both instances available, so we'll view control first, and then we will open DSP, tile these, and we can see the processes running on each of these. Now that our two kernels are running, let's start some applications on them. I've got a Jitter application, which I can run one instance on each kernel. This Jitter application shows us the accuracy of the timer interrupt. Now remember, DSP is running at a 100 microsecond tick rate, and control is running at a 500 microsecond tick rate. This graph measures the variation about that tick rate of our response to the timer interrupt that's used to generate this tick. So every 500 microseconds on the core named control, there's a timer interrupt, and our response to that timer interrupt is no worse than a microsecond. Likewise, on the core named DSP, every 100 microseconds there's a timer interrupt, and our response is within 1 microsecond. Let's make the system busy by starting up some applications. Now I've got an intensive search taking place here on the disk. I've got Windows Media Player playing a piece of music. I've got Task Manager running so we can see what the load is. And I've got a video running in another window here with a separate application, multimedia application. Task Manager represents the state of the Windows side of the system. So remember, Windows is running on cores 0 and 1, and you can see there are only two cores represented here because core 2 and 3 contain the INtime kernel, and we're within 1.5 microseconds with the system busy like this. The load of the system does not significantly impact our ability to respond to that timer interrupt and do hard real-time work.